Here's our next exponential equation. The only difference on this problem is now I have an x in the exponent on both sides, but my process is going to be no different. In fact, the new step of taking the log of both sides is going to be nice and easy. We're going to have to go through a little bit of algebra. On this problem, I'm not going to worry about the decimal approximation. I am sure you all can use your calculators. I'm going to leave my answer as the exact value. So here goes. Since my x is in the power, I am going to take the logarithm of both sides. So I've got the log of 2 to the x plus 3 power is equal to the log of 5 to the x power. Once again, the reason we do this is we are going to take advantage of the power rule of logarithms, and we're going to move those powers down in front. Now, here's the thing to remember. This power is a binomial. We're not going to forget to distribute. So when I bring the x plus 3 down, I've got x plus 3. I'm going to put it in parentheses to remind me to distribute, times the log of 2. That's just a number. That's great. And then on the right side, I've got x times the log of 5. So I'm going to distribute over here. So I've got x times the log of 2 plus 3 times the log of 2 is equal to x times the log of 5. Okay. So this term right here, 3 times the log of 2, that is just a value. We can find that. We know that. So my goal here now is I'm going to get everything involving an x on the same side so that I can get the x by itself. This is what we do in any sort of linear equation that we're solving. Just here, the coefficients are in terms of logarithms, so it makes it look more complicated. So I'm going to take this term right here involving the x. I'm going to put it over on the right side of the equation by subtracting it. So I'll write that down so that you can see what I'm doing. Now, please, 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 I beg you, do not say, oh, x log 5 minus x log 2 is x log 3. That's not how logarithms work at all. Okay, so these two things are not like terms. Don't make up new steps. So what I've got now is I've got 3 log 2 is equal to x log 5 minus x log 2. We are almost done. That's the hard step. Here's how we're going to finish it. I am going to factor out the x that both of these terms have in common. So I've got 3 log 2 is equal to x times log 5 minus log 2. And now log 5 minus log 2, that is a value we could find if we were so motivated with our calculator, but there is no variable here, so my last step is to divide both sides by the log 5 minus log 2. And that gives me this x is equal to the 3 log 2 on the left divided by log 5 minus log 2. This is a value. You can find that using your calculator. The book gives both types of answers. I'm going to do one more thing because good notation. I write my solution as a set. I'm sort of out of room, so I'm just going to be lazy and put some squigglies around that. That is my solution set.